I'm going to start part B, homework 1, part B, question 1, drawing an image. So I'm going to draw the two cylinders, one within the other. And they are going to have a height of h, and then there's going to be a wall in the middle of them, which will look like this, drawn in red. And this wall will have a certain thickness, which will be t. So we have a height and a thickness, which gives our area, and there's two of them. So our expression for this is going to be 2ht. And then there is a tensile strength that holds this together. So the expression will become 2ht sigma, which gives the max force these cylinders can handle before being split apart, because we're looking for perpendicular forces. And because we're looking for those perpendicular forces, we'll use cosine and the area of RD theta, theta. And then due to equal and opposite reactions, our limits of integration are pi over 2 and negative pi over 2. So to find the total forces, cylinders start with F total, which is equivalent to the integral of dF cosine theta. And then our dF can be broken into P dA. And don't forget the limits of integration on this integral, which are, again, pi over 2 and negative pi over 2. And then if you can break this down even further, so you get your F total equals the integral of pi over 2, negative pi over 2, P dA cosine theta, which breaks down into the RD theta that we had stated earlier. And that's just the dA, not the P, so let me fix that. Erase that, and it's just dA, which breaks down into RD theta. So then, plugging all this in, it becomes integral pi over 2, negative pi over 2, PR d theta cosine theta in 2D, and we need it in 3D. So our F total would then become integral pi over 2 to negative pi over 2 of PR d theta times cosine theta, but we are going to add h to the end of this. So cosine theta h. The h is important because that makes it 3D. So now we can take all of our constants out, which is PR and h. So then our F total would become PRH integral of pi over 2, negative pi over 2, d theta cosine theta. So then completing this integration, excuse me, integral of cosine theta is sine theta, and then pi over 2 to negative pi over 2, it becomes 1 minus negative 1, which equals 2. And then that now becomes our F total, which is 2 PRH, is our finished expression. And then taking the expression from above by the cylinders and bringing that down as our F total, you set these two expressions equal to each other. So you get 2HT sigma equals 2 PRH. And then you can cancel out the 2's, and you can cancel out the H's, and then you're left with T sigma equals PR. And then to get T by itself, because that's what we're solving for, you take sigma and divide PR by sigma. So then your final expression becomes T equals PR over sigma. And that is it. Question 2 is the same as B1, but for a spherical thing instead of cylindrical. So you have a circumference of 2 pi r when you have a sphere. So let's write that down, 2 pi r, and then you multiply by the thickness, which would give the area of the sphere. So then your area is 2 pi r t, and then you need arc length to derive area for inside the sphere, which is given by RD phi, that's RD theta, which is in the YZ direction, and then sine phi d theta gives the arc length in the XY direction. That's what it was. Sorry. And so now to derive the forces acting inside the sphere, we're going to start with Fy, the forces in the y direction, which are equal to dF times sine phi sine theta. And then we take the integral of that. But dF breaks into PR sine phi d theta times r d phi. So then plugging that in, Fy equals the integral of PR sine phi d theta times r d phi times sine phi sine theta. Very long expression. Sine theta. So we're only looking at half the sphere, so we'll integrate from 0 to pi, and then p and r are going to stay constant, so we'll pull them to the front of the integral. And then that would give us, there's two r's, so those will come out front as well, and our new expression will be Fy equals PR squared times the integral from 0 to pi of sine phi squared d phi times sine theta d theta. And then using angular addition, which is cosine A plus B equals cosine A cosine B minus sine A sine B. Let me just write this out. And then we also know that sine squared phi plus cosine squared theta would equal 1. So and cosine squared phi would then equal 1 minus sine squared phi. Or it's, yeah, sorry, phi instead of theta. So then, using that method, we would get PR squared integral 0 to pi sine squared phi d phi plus the integral 0 to pi of sine theta d theta. And then, now using this method, plugging it in, we would get that the then we have cosine 2 phi, and this becomes cosine 2 phi, which equals 1 minus sine squared phi minus sine squared phi, which equals 1 minus 2 sine squared phi, which is getting a little cut off. Sorry about that. And then moving forward from there, we would do, there we go, now you can see it. Kind of. So then moving forward from that, you get sine squared of phi, which then becomes cosine 2 phi, and then minus 1, which equals 2 sine squared phi, which then equals sine squared phi, or becomes sine squared phi, which equals 2 phi over cosine 2 phi over 2. And then plugging all of this in to our expression, we would get our Fy equals PR squared times the integral from 0 to pi of 1 minus cosine 2 phi over 2 d phi times the integral 0 to pi of sine theta d theta. And then to solve the phi part of this, we would use u sub, or u substitution. So for that, to do that, we would want our u value to be 2 phi, and then our du value would be 2 d phi. So then if we plug that in, I'm plugging all this into that integral there, we would take the integral from 0 to pi of 1/2 minus cosine 2 phi over 2. And integrating this, we would get 5 over 2 evaluated from 0 to pi minus 1/4 0 to pi integral 0 to pi of cosine u du. And 0 over phi becomes pi over 2 minus 1/4 sine of 2 phi. It's just evaluated from 0 to pi. Sine of 2 phi from 0 to pi would equal 2. And then pi over 2 times 2 just becomes pi. And from there, we get PR squared times pi, which would equal 2 pi RT sigma. That's our tensile strength coming from the circumference equation. So we lose the square, the pi's cancel out, the other r cancels out. And then for t, you are left with 2 PR over sigma. Right? No. 2 PR over 2 sigma is what you're left with. Hang on. So, bring this bad boy back down. Hang on. Okay, we got there. Let this move. Pi over 2. So then your expression would become PR squared times pi equals 2 pi RT sigma. And then your r's cancel out, your pi's also cancel out. So I'll get rid of those. Well, one of the r's on the left side. And then that cancels out. So then to solve for t, you are left with not 2p. You're left with what is PR divided by 2 sigma. And that is the equation. So then to solve for t, we are left with just t equals 2p. Nope, sorry. That's wrong. You are left with PR over 2 sigma. And that is our equation for the thickness necessary. So then for question 3, we're asked how could the results from B1 and B2 be obtained through a choice of dividing plane through cylinder and spherical tanks. I'm just going to talk about this one. Just that the dividing plane is chosen such that the pressure forces on one side of the plane are equal to the pressure forces on the other, which is what needs to be done to ensure the minimum wall thickness is the same on both planes of the wall and of the cylinder or sphere. Yeah.